welcome back.
Howdy.
Hello.
Hello.
Hello. I know you guys are tired because it's the end of the day. We're working on simplifying radicals. Before I can get into what a radical, like how to simplify it, I want to take a moment to remind you from Algebra 1 what a radical is. And I want to do it in a way that will extend for you into next year's Algebra 2. Okay? So when I say radical, I mean that symbol. And it's got a couple of different parts to it. Okay? The first part, the part that you're familiar with, is this part inside right here. This part is called the radicand. So you're going to hear me say something about a radicand. I mean the stuff inside. Okay? The other part that we're going to talk about is going to be the index. I'm going to write it with a little I for index. So that's going to show up. Now, right now, you've seen square root without a number up there, right? It just has, there's no number, like these, like this one. There's no number up there. Well, if there's no number in the index position, it's a 2, okay? Which is why it's called a square root, okay? The last part that you're going to see is right here, this exponents, which is some sort of power, some sort of number. Okay? The exponent on the radicand. All right, feeling okay? The different parts? Quick math anatomy lesson for you. All right. Let's talk about the square root. Okay? So with this generalizes, it can handle any index. Now we're going to talk about the one where the index is 2, the square root. In order to talk square root, we need to talk about perfect squares. So I'm going to slide my paper over so that we can look at perfect squares. These are the perfect squares. They're perfect squares because I can take a number, multiply it by itself, and get this list. 1 times 1 is 1. 2 times 2 is 3 times 3 is 4 times 4 is 5 times 5 is 6 times 6 is 7 times 7 is 49. 8 times 8 is 9 times 9 is 10 times 10, and 11 times 11 is 121. And then 12 times 12 is 144. If you don't have these memorized, it's okay. We've got calculators. But I'm going to urge you to try to get these memorized, at least the first part of it, because it'll make some of what we're going to do next much faster.
Is it 36 before the 49?
It is a 36. Now, we did these with numbers, but we can also do them with things with exponents. Okay? X squared, x to the 4, x to the 6, x to the 8, because this is a pattern. X to the 10. Notice that when we're dealing with perfect squares with exponents, the exponents are needing to be even, that we can divide them by 2. Okay? 36, the square root of 36 is 6 because 6 times 6 is 36. The square root of 100 is 10, because 10 times 10 is 100. The square root of 49 is 7, because 7 times 7 is 49. Let me extend it into Algebra 2 for you a moment. The square root of 49 is 7, is not the only answer. Because a negative times a negative is a positive. And so negative 7 times negative 7 is also 49. So all of these square roots have 2 answers. They have the positive number answer and they have the negative number answer. We're going to focus on the positive numbers in this class for this year, but I want to put that just in the back of your head so that way next year when they talk about it, you don't go, what? At the very least, you go, oh yeah, my crazy teacher last year talked about that. I kind of remember, I don't really remember, but she said something like that, and okay. All right? Okay. We can do this with exponents. The square root of m to the 16 is m to the 8 because 16 divided by 2 is 8. What? Okay, let me slow this down for you. I took the power of the radicand and I divided it by the index of the radical. Okay? And I'm showing it to you this way because I know that when you hit Algebra 2, there's an entire section that does this. And if you can kind of get it a little bit here this year today, the next year gonna be best.
Is 2 divided by?
The 2 is going to be the index. When it's not written, it's a 2. Okay? Turns into easy division for you. Cool? All right. So the square root of y to the 10th. What's the index?
2.
The index is 2. So I'm going to do 10 divided by 2. 10 divided by 2 is? That's the exponent of my answer. What about the next one? A squared. The square root of a squared is? What's the index of this radical?
2.
2. So I'm thinking 2 divided by 2. 2 divided by 2 is? 1. Do I need to write the 1 exponent? No, so I'm not going to. Save myself some ink. All right? It's very possible that the radicand, the thing inside, is not an even exponent or is not a perfect square. Let's deal with the numbers first. Let's deal with perfect squares first. Take a look at example number 1. So example number 1 is 18. 18 is not a perfect square because 18 lives somewhere between 16, which is a perfect square, and 25, which is also a perfect square. Somewhere in there, which means 18 isn't a perfect square. So first thing you need to do is think to yourself, what are the factor pairs of 18? What 2 numbers do I multiply together to give me 18? 9 and 2. Any others?
No, 6 and 3.
6 and 3. Any others?
5 and 2.
That's 10. What about 1 and 18? Oh, yeah. That's all of them. All right. So I've made a list of all the factors. Now, as I'm looking at these, I'm going to tell you right now that any factor pair that has a 1 in it, while you're not wrong, it's not helpful. So we're going to throw that one out. So when we're making our list, we don't have to think about that one. As we're looking at our list, we're really looking for the pair that has a perfect square. 9 and 2, because 9 is on our perfect square list. 9 is 3 times 3. So this is going to be the factor pair that is going to help us. And so I'm going to think of 18, not as 18, but as 9 times 2. And so I'm going to rewrite it as 9 times 2. Okay? So far, so good? Now, anytime I have a radical, and I've got inside of the radicand a bunch of multiplications, I can take a knife and I can cut the radical everywhere I have a multiplication. Chop. And now I have 2 radicals. It looks messy, but I can look at it 1 radical at a time. What's the square root of 9? 3, because 3 times 3 is 9. So I'm going to replace the symbol for square root of 9 with the symbol for 3. And then I can look at the other radical. There's nothing to do. So I'm just going to bring that down. I've done everything I can do, and so I'm done. So that's the answer. If I say I want this radical simplified exactly, you have to do this thing. You can't give me a decimal. Okay, so if I say in exact terms, it's this thing. Do you want to see another just the number example?
Like similar to this.
Similar thing, but with a different number, like number 2. Yes? Okay. Number 2. I want factor pairs of 125.
Can you move these up?
Yes. Okay, so numbers that multiply together to give me 125. 1 times 125. Okay. Which we're going to end up throwing out because it's not going to be helpful. But, I mean, we can tell. She's not wrong. I'm going to write it down. It's just we're not going to use it. Because when we have, I think she was in the restroom when we had this conversation. For what we're doing, the factor pair that has the 1 times thing isn't going to be helpful. So we're going to end up throwing him away.
No.
So you're not wrong. It's a factor pair. I wrote it. You're not wrong. We're just,
25?
we're not using it. 25 and
5.
25 times 5. Does this pair have a perfect square? Yes, so we can stop. We don't have to look for any more because we found a pair that's going to work for us. So I'm going to rewrite 125 as 25 times 5. Now if you notice, the printer has the radical without a little tail, and when I'm handwriting it, my radical has a tail. This is because when I was your age and I was doing this, and I was learning radicals for the first time, I had a really bad habit of not putting the bar all the way across, and so numbers would fall out of the back. Like you're driving along your truck, the bed of your truck is full, like you're driving and just stuff falls out. That would happen with my numbers. And it would make a big mess and I would get the wrong answer all the time. And I almost failed my math class a couple times because of that. So I learned to put a tail, closing the tailgate of the truck so stuff doesn't fall out the back. So if you're worried that stuff's gonna fall out the back, close the tailgate, okay? You don't have to if you're a much safer driver than I am, but I'm a wreck. Okay. I can take a knife, cut at the multiplication, yes? All right, cutting at the multiplication. I now have 2 radicals.
You can't do 5, right?
You're right, because I don't have a whole number times itself that gives me 5. But I can do 25, because 5 times 5 is 25. So 5 times 5 is 25. I'm going to replace the symbol for square root of 25 with the symbol for 5. And there's nothing more I can do, so I'm done.
I thought you could only put like a 5 inside the inside.
Oh, you meant putting this 5 in here?
Yeah, only like that.
Okay, no, because the square root of 25 is 5. Like they have the same quantity.
Put both of them, right?
Yeah, so I need to put this 5, and then I need to deal with this square root of 5.
So basically, the one that's on the left is the smallest thing used to multiply to get to the number you
This one,
Yes.
this number right here is what I have to multiply to itself 2 times to give me this number inside of here.
But it's like the minimum number.
When I'm doing these factor pairs, I actually want to try to find the one that has the biggest perfect square. Otherwise, I have to do this step more than once. And so in an effort to do less work, I want to try to find the biggest perfect square. Great question. Thank you. All right, let's do one with some letters involved. So as I zoom out here, 7 looks like it's complicated,
Or, no, 8.
or 8? 8? Okay, we'll look at 8. So I'm going to zoom back in on 8. All right. So as I look at this, I notice I got a bunch of stuff, and it looks really intimidating. But there is multiplication between each one of these things, right? And so I can take out my knife, and I can cut it at each one of those multiplications. And so I'm going to think of it as 3 radicals to work with. And I know what you're thinking right now. But you've just made it a longer problem, and it looks more complicated, right? Except, now I can do that. And now I'm looking at just one radical. Square root of 27. 9 and 3, I can think of 27 as 9 times 3. which is helpful because then I can break this at the multiplication, and I know the square root of 9 is 3. And then there's nothing to do for square root of 3, and so I'm just going to write that. Okay? And so I've done just one radical, and now I don't need to worry about that piece. Okay, now I'm going to look at the next radical. A to the 11th. What's the index?
2.
2. So I'm going to think 11 divided by 2. Okay? I'm going to do my work over here. I'm going to think 11 divided by 2. Do you remember doing that? Like in elementary school? Right? When you're first learning long division? Okay, so what do I need to put up here?
2.
2 times something gets close to 11. 5. Because 5 times 2 is 10. Subtract what's my leftover? Remainder 1.
Wait,
Do you remember doing this?
Wait, hold on. Like, does the 5, like, is that like the number, and then the 1 goes on the bottom, like on the, does it make a fraction?
It's going to end up making a fraction. You look, you think, yes, you're right, but hang on to it. Let me show you how we're going to write it. Okay. All right, this number right here. This becomes this exponent out here. The remainder becomes this exponent right over here. You're right with the fraction. It would be written this way as a fraction. You're absolutely right. And actually, it's what we're doing. I'll show you later. And then you're ready for like calculus. All right. Make sense? Okay, let's do it again with this one. I'm going to leave this here for now. Let's do it with this one. Okay, we're going to take 7 divided by 2. 7 divided by 2 is 3, she said. 3 times 2 is 6. Gives me a remainder of 1. So this is the power of the thing outside. And because I have a remainder, I have something inside of a radical. That's the power of that thing left in the radicand. Now I need to write my answer all the way down. Oh, are people still writing this? Sorry. All right, so there's my answer, but it looks weird, right? Because we're used to only seeing one radical, and we're used to seeing all the things multiplied together, kind of all mashed together. So what I'm going to do is I'm going to take these non-radical parts, and because multiplication is commutative, I can move stuff around, I'm going to shove those all up to the beginning. And then I'm going to take all the radical parts, I'm going to mash those here at the end. Do you remember when we started this problem? I said that since we have multiplications, we can cut at the multiplications. Well, now I have a bunch of radicals with multiplication between them. So I can take some glue and undo the cuts. And I can rewrite all 3 of those radicands, all 3 of these radicals as a single radical with those individual radicands all multiplied together. There's only one thing you have to be careful when you're doing this gluing. The indexes have to be the same. Are the indexes the same? I don't have anything written, so yes, they're the same. This becomes important when next year we have algebra 2 and we change the index. And suddenly you have a problem with like an index of 2, not written. And an index of 3, that'll be written. And an index of like 7, that'll be written. And they're all in the same problem. And you can't multiply those this way. Okay? They'll clarify that for you in algebra 2. For right now, you're pretty much safe multiplying all the radicals together. Okay? Does anyone want to see any other examples before I get ready to dismiss band? for Pepperell? Okay. Thank you very much.